All right. Well, looks like it's working. Is that one working? Okay, that works. Well, all right. So that one works as well. Is everybody ready? I'm a little bit late, but so my talk will be on memory forensics with Hyper-V virtual machines. So basically, I'm going to cover a little bit of the virtual machine layer and as well as the host layer. My name is Wyatt Roersma. If you're curious, you can follow me on Twitter at Wyatt Roersma. So it's very simple. Who am I? Just basically give you some background on who I am. My name is Wyatt Roersma, obviously. I'm a senior security engineer at nVent. I also do some, I kind of create some digital forensics challenges for Blackfin Security, and I also do some content development for the Hacker Academy. I don't know if anyone's familiar with those, but I also research for fun, and I do a lot of work with volatility. I don't know how many people, first of all, are here familiar with volatility? Awesome. That's what I like to see. So I'm not talking to like completely, like, hey, yeah, I don't know what the fuck you're talking about. That's great. Sorry, there'll be a little bit of vulgar language in this, so that's what it is, right? So why am I doing this talk? Who gives a shit, right? Better understanding of Hyper-V virtual machines. There's really not a lot of research out there in terms of memory forensics for Hyper-V. Why? Because not a lot of people care. While at the same time it is actually gaining a lot of momentum in the virtual machine market. A lot of people aren't aware of that. It's actually starting to take a dent in the x86 64-bit platforms of VMware. They're actually starting to care. Right? My business does it, so whatever, right? Anyways, so basically I work with a lot of Hyper-V servers, so this actually has some use for me, and that's kind of why I did it. And well, they kind of paid for the talk, so I figured I would kind of make it sort of relevant, and spending lots of my own time doing, not a lot of business-related things. And you need a lot of better documentation for the Hyper-V forensics analysis. And then, as this, kind of show you that it sort of does matter that, Hyper-V accounts for 28% of the hypervisor market share. And I have a reference at the end if you don't believe me. That's great. So what's the agenda of this talk? I'm going to talk about the Hyper-V architecture overview, just kind of give you a basic understanding of it because it doesn't really work like a lot of hypervisors. And then we're going to kind of go over the Hyper-V virtual machine, kind of give you some basics on it, go through a little bit of acquisition tools between 2008 R2 and 2012 R2. Kind of give you the caveats, ins and outs, pros and cons, et cetera, et cetera. And then a little bit of the Hyper-V host layer. So in kind of doing some forensics at the root partition layer. I'll get a little bit into the root partition a little bit later. And then I'm going to reveal some of the Hyper-V plugins that I have specifically developed to release at this conference. So these have never been released before. I submitted them to the Volatility Plugin Contest. However, no one else has seen this yet. So your first time. And then conclusions Q&A. I also have a book to give away. So Art of Memory Forensics. How many people are familiar with this book? Awesome. Does anyone know what the original volatility project started out as for a name? What was it originally named? Does anyone know? Other than Sean, because he doesn't count. All right, so that was the only question I could give one of the questions I give away a book on. So moving on, just kind of give you a basic background of how Hyper-V works. So what you have is the root partition. So a lot of people think when you install Hyper-V, it's not necessarily like ESXi. However, when you install the role Hyper-V, it actually creates that virtual machine. It takes your host system and turns it into a virtual machine. Not a lot of people are aware of that. And actually what they call it is the root partition, which I referred to a little bit earlier. And everything kind of communicates with the VM bus on that or the hypervisor layer, which is actually above the Hyper-V partition. So if you're using any memory acquisition tools, you're never going to get the hypervisor layer unless you're running a nested virtualization configuration. Does anyone understand what nested virtualization is? So virtualization server on top of virtualization server. That's the only way you can actually acquire the hypervisor address space because any of the FTK imager, fresponse, the best tools out there, they don't actually acquire the hypervisor memory address spaces. This is why a lot of plugins to do virtual machine introspection don't actually work with Hyper-V, which is very similar to the Zen platform. If anyone's familiar with Zen, the type 1 hypervisors, it operates above where you're at. So you actually don't have full access to that. While the root partition has the most access, It doesn't have everything. And then everything else is a enlightened partition, is what they call a child partition, whether it's running Windows or Linux, and that all communicates with virtualized drivers to either the root partition or through the hypervisor itself. And anyways, so to get into some basic understanding of Hyper-V, so not a lot of this is important. I'm pretty sure you all kind of get this, right? So like I said, the child partition is a partition that hosts a guest operating system. All access to physical memory and devices by a child partition is provided by the virtual machine bus. So basically, it doesn't have actual direct access to memory. It has no way of locating memory itself. That's all done by the root partition's processes. And then the root partition is, like I said, that's the machine you install the Hyper-V role on, and then becomes a virtual machine. Not a lot of those are really important for this talk. This has been used for a few different conferences. So the most important things we're going to talk about today are the virtual machine worker process. So every time Hyper-V creates or starts a VM, it will spawn a virtual machine worker process. And that controls everything that has to do with that virtual machine. The start time, its memory management, so on and so forth. And then you have the VMS, the Virtual Machine Management Service. It's kind of responsible for managing the virtual machine state outside of the virtual machine worker process because, well, the virtual machine worker process can't start itself. So that's kind of what manages all that. It does a little bit of the network I/O stack in that sense, and then a little bit more than that. Not really in the scope of this talk, though. None of this other stuff is going to be super important. So to give you kind of a basic understanding of Hyper-V, is everybody familiar with the VM SS format with ESXi, where it stores the memory? So Hyper-V works sort of similar, except it doesn't store it in a raw format or basically raw format like VMware. It stores it in a bin and in VSV. So the bin is basically your physical chunks, and the VSV is your metadata that kind of interprets and tells you how the physical chunks will locate to memory address spaces. And then you got the XML, which is the virtual machine configuration file. It tells you everything about the virtual machine, what hard drives are attached to it, where the snapshots are at, blah, 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 blah. And as you can see in my picture, every virtual machine is created with a GUID that's unique to the virtual machine, and all the permissions are based on a user that is that GUID. That's the name of the user, and the only thing that has access to that is that user, and they have no access to anything else from the root partition in those that terminology. As you see here, I kind of like gave you a little example of what some of the snips of the XML file are, where you can see the GUID, you can see the VHD file, that's the hard disk file that is associated with Hyper-V. And then if you actually browse the directory, it depends on where it's at. You can actually store this in different directories, obviously. It just depends on where you store it. This is the default directory, program data, Microsoft, Windows, Hyper-V, virtual machines, and then the GUID, specific to the virtual machine is storing for. That's where your bin and VSV files are at. Those are your memory information. So then we're going to talk about acquisition tools. How can we work with Windows Server 2008 through 2008 R2? Microsoft released a plugin, or not a plugin, but a tool on TechNet called VM2Dump. And unfortunately, they no longer support it, and it's actually taken down. So if anyone wants access to this tool, you gotta email me, because I don't know if anyone else has this tool available on the internet for download. No idea why they took it down. It stopped supporting 2012. It doesn't support converting 2012 images or 2012 R2 images to a raw, well, not a raw memory format, but a crash dump format. So basically, with the Windows debugging tools installed, you can take a VSV and a .bin format and convert it into a crash dump, which, if you're familiar with volatility, you can either convert that into a raw file, or you can analyze it with the crash dump address space that supports in volatility. The problem with this tool, however, that I found is that it has a 4 gig RAM limit. So if you have a virtual machine that's larger than 4 gigs, you can't convert it. And one of my biggest caveats is if you have a Linux virtual machine that's saved, you can't convert it at all, because it doesn't have the symbols to do that. It only supports converting Windows virtual machines, which is a complete nightmare and not really helpful. So just to give you an example of how to use this tool, VM2Dump, you specify the bin directory, then you specify where the VSV is at, and then you specify the output crash dump file that you want to make. Pretty basic, very easy to use. You can do it on a virtual machine that's running. You can run it on a snapshot image and get a crash dump format of a Hyper-V virtual machine that you can analyze in volatility. And then if you have your own symbols path, you can specify that just like you would with the Windows debugging toolkit. And so acquisition tools for Server 2012 and 2012 R2, there's livekde.exe. Some people have a problem with this because it relies on some Windows API calls that can be interpreted by malware. That's only if the malware is running on the root partition, which if your host is infected, you're pretty much screwed anyways. But it's a semi-valid method to acquire memory from a virtual machine that's running on your system. Still has the problem, however, that it only converts Windows virtual machines. It doesn't have that RAM limit of 4 gigs, but I can't convert the Linux virtual machines on my system. That's kind of a nightmare, right? And like I said, Windows API, and then to mention another tool I'm not super familiar with, but livedump.exe came out in August of this year. They claim that you can support dumping the address space of a virtual machine out without relying on the Windows API call. I've tested that tool. It's kind of inefficient. So, not really anywhere with that yet. So, examples of livekde. If you want to list the virtual machines, that -hvl will tell you all the virtual machines that are running the system. Obviously, if a virtual machine is saved, it's not going to list it there. And then if you want to convert a virtual machine named AD, you can just do livekde-hv80-p, which indicates you're pausing it. The -o is the output, and the AD dot into the crash dump format. Or you can also use the GUID of the virtual machine. We'll get a little bit into that in just a minute. But typically, I'd recommend to pause the virtual machine if you're going to use this tool, because if you don't pause the virtual machine, you're going to have a lot of, what's the word I'm looking for? Smearing. Thank you. So if you don't pause the virtual machine, you're running a lot of smearing, and that will cause a lot of tools to have issues, especially if you're not using volatility. If you use redline, it's probably going to break anyway, so that's irrelevant. Anyways, so Hyper-V host memory analysis, kind of diving more into the root partition. So basically, I've done analysis on images larger than 148 gigs on a daily basis. How many people have done memory analysis on an image larger than 256 gigs? Okay, so I've dealt with a little bit of those, not too frequently. Typically, like the reason I have 148 in there, that's typically what most of our host clusters run at. It's pretty much a nightmare because it takes a super long time, and if anyone's familiar with volatility, about half the crowd, volatility already takes a little bit of time to run, and then you run on a massive image, and even if you're on a solid-state drive with a fast processor, it's going to take forever. That's just the nature of the tool. But the reason I like the host memory analysis is because this allows me to analyze a lot more artifacts, and especially not rely on the API call. I can take a memory dump of a Hyper-V server, and there's no way for malware to really understand that I'm doing that, especially if you're not using a built-in API reliant tool or a PowerShell-based tool that malware can, blitz into if it's somehow on the root partition. This also gives you a lot of network artifacts. So if anyone's familiar with the EtherCap plugin that was released last year by Jamal, I can't remember his last name, you can actually dump out a lot of packets from the virtual machine image. The root Hyper-V virtual machine image will actually give you all the packets of the virtual machines on it. So it's kind of interesting. We'll get a little bit of those network artifacts in a minute. And to give you a basic understanding, so I talked about the virtual machine worker process. It's the executable virtual machine worker process. This is what controls each virtual machine. You got the VM switch.sys. It's your driver for the switching stack. And then you got the vhdump.sys is your kernel driver for the storage. Those are just some things you might see later on. For this example, I created a nested virtual machine so I could do proper analysis on the system. So you have a Hyper-V host, and then you have 4 virtual machines running on top of that, all of which pipe through this virtual Pfsense firewall that's on the server. So all the virtual machines are passing through the Pfsense firewall before it actually even touches the host networking stack, and then goes out to the WAN or internal network, depending on how you have set up. And I also, in this scenario, I have a security onion virtual machine that is monitoring the virtual machine Pfsense port. Unlike ESXi, Hyper-V actually allows you to monitor traffic to any VM you want and then port that to another virtual machine on the system. So that's one of the reasons I like it. There's caveats and good and bad to everything, right? So this is one of the reasons I don't totally hate working with Hyper-V. It has some interesting features. To kind of get more into what I've actually developed for Hyper-V and kind of make my daily job easier, I got a HPV VM Connect plugin. This basically will tell you, as you can see, who is logged in the system. As you can see in the username Wyatt, and it will tell you the user domain name of who's connected to it, the create time. So the create time basically stands for when they open that connection to that virtual machine. It's just like a vSphere console to a virtual machine. So you know exactly when they opened up essentially an RDP remote access to that server. So you know exactly when they started their session. That can be very useful in a forensics investigation, especially if you're like me when you're investigating a potential compromise of a host server. And it also will give you the virtual machine GUID, which is that unique identifier I've been talking a little bit about. So that's the first plugin I developed. It's pretty basic. It tells you kind of the PID and the time and the host computer name that it's running on, because you can connect to any Hyper-V server from any Windows PC that has the Hyper-V manager installed on it. So this can be used on any system that potentially has the the vmconnect.exe plug or executable running in memory. And it can give you lots of information about it. I'm working on getting the host name for the virtual machine it connected to, but none of this is really documented by Microsoft, so it involves a lot of reverse engineering, so I'm pretty slow at that, unfortunately. Kind of trying to speed that up. Anyways, so the second plugin I developed is the HPV. This is basically designed for the virtual machine work process. This will tell you every virtual machine that's running on the host server that you took the memory dump from the root partition. It will tell you the PID, the parent process ID, the create time, so basically when that virtual machine was started, and it'll also tell you the GUID, so you know what process is running what virtual machine. This can be very valuable from a forensic standpoint, because if you actually dump out the strings from the VAD of that process, you can see everything from network connections to actual memory address spaces. Now, it's not the full memory address space, but it will show you a lot of recent information that has been accessed from that virtual machine. And obviously tell you when it was run and that type of information. The third plugin and final plugin that I've developed so far, I have a couple more in the works, but is the HPV clipboard plugin. This will basically, if anyone's familiar with Hyper-V, how many people actually worked with Hyper-V in here? Okay, that's actually more than I expected, typically anyways. So when you do the type VM text, basically the paste of clipboard text into a virtual machine, this plugin will list out any text that was pasted into a virtual machine. First of all, I'll tell you which virtual machine process that it was pasted into. As you can see, the clipboard data simulating typing Control-Delete, and the Control-Delete was completed successfully. If that's a Linux machine, it wouldn't complete successfully because there's not that type of integration for Linux virtual machines in Hyper-V. And as you can see actually down here in the ASCII characters, this is the password that was used to log into the virtual machine, because who wants to type that out? I don't. And that's kind of why the plugin exists. It can tell you a lot of important information, especially if your host is compromised and you want to see kind of what they're running in the virtual machine. Which, if anyone's doing is anyone participating in the Digital Forensics Challenge right now? So that's one you're really going to want to watch out for. That's used in the challenge, so just so you know. And it kind of gives you more information of how the virtual machine worker process works. I can actually, on the root partition's memory dump, grep my security onion server and find, as you can see, if anyone's familiar with security onion, these are, IDS alerts, which is interesting from the root partition, right? Like, hey, that's a lot of data. There's really no good way of analyzing it in a sense of like, hey, I can scan this one virtual machine. Yeah, I'm actually working on that. Some bugs in that process, but hopefully I get there. So if you want to figure out what a virtual machine was doing, you can dump out that process, kind of dump out the VAD of that process, and then start searching through strings. Be a lot of useful information, especially for my Pfsense firewall. As you can see, just as an example, it shows you the name servers that the Pfsense firewall is using. Is anyone familiar with these name servers? Hands? Does anyone know what these DNS servers are? Okay, well, since you're the only one to participate, get a free book. This is the first giveaway of the signed Art of Memory Forensics books. And there's just an example of the type of data you can get in there. You can actually get a lot more of information of really any kind of network traffic, especially that goes on in the system. And then other types of information. It kind of depends on when you take the snapshot of what data is going to be available in that process's address space. So, and just to further iterate how much data is actually available in memory, and like I said, this isn't guaranteed. There's no, like, this is not the full address space of the virtual machine. That does exist in the memory dump, just not in a way that I've actually been able to map properly. There's a few bugs with that process. So as you can see, it's FreeBSD just by scanning the address space of that, the VAT of that process that runs that virtual machine. So that's really useful from a forensic standpoint, especially when you're trying to determine what potentially ran on the system without actually obtaining a memory dump from that system. And then, as a conclusion, I kind of went a little bit faster through that I expected, but the reason I think it's so valuable to do hypervisor forensics is if you're running your firewall on the system, you can do analysis on your firewall, which isn't available on a lot of firewalls to date. Which, I don't know if you're like me, I kind of want to know if my firewall is pwned. I actually heard recently that Cisco is actually working on capabilities of dumping out memory from their devices, which is a huge leap forward in terms of networking devices, because that's, I don't know about you guys, that's one of my biggest problems with a switch or a firewall, or there's no way to analyze it. Like, how am I going to know if it's pwned? Like, there's literally very few ways to determine that. Because, I mean, a firewall's not going to tell you if it's pwned. It's not going to be like, hey, dude, I got hacked recently. Great, right? So I feel like that's really important in our industry because, honestly, routers and switches and firewalls, some of the most unpatched devices and control most of the network. So if I was going to be an attacker, that's kind of what I would attack, and I've seen it before as well. So there's a lot of usefulness in doing, running everything in a virtualization environment where you get to see the switch, the router, the firewall potentially, and you can actually do an inspection on all of those systems before, how long it takes each vendor to make memory analysis capabilities available for their firewall. So if anyone wants, any more information, I'll be releasing more information as it becomes available and as I get time. You can check out my blog at WyattRoersma.com. And then, so I don't know if this is useful to anyone that's plugged in. If anyone's using Hyper-V, check it out. Let me know if you find any bugs. It's very, incident specific, but it can be super useful. Does anyone have any questions at the time? Yes. Huh? Soon. I don't know why that's actually not working right now. Which is a great answer, right? Hey, man, I appreciate it, actually, It's kind of a stiff crowd sometimes, and you're like, I don't know if these guys think I'm an idiot or something. So, yeah, I was hoping for more, honestly, but I'm calling myself an idiot up here, like, what would you do, right? How did I just go through that fast? I was trying to give you a reference slide. Okay, so if anyone wants to see the references, I already went through it. So these are references. If anyone wants this from me, I'm going to make this presentation available. A few different links that you can find, especially about the plugin I just released today. That's going to be useful in the Digital Forensics Challenge. And then, any other type of information you want, just let me know. If anyone has any questions outside of this, please feel free to contact me. I'm always available. I'm happy to discuss anything related to security, incident response, digital forensics. Do we have any more questions? All right, how fast did I just go through that? Way too fast? Where are we at? Well, that's honestly all I have, so thank you guys for your time. Appreciate it.